Good evening, good morning. Welcome to PSC Online Workshop. This is today's workshop is on LIDAR Technologies and Applications. And before I really launch into the workshop, I'd just like to do a quick introduction of Photonics Society of Chinese Heritage. We are a nonprofit organization dedicated to promote friendship and collaborations among global engineers and scientists in the field of photonics, so they can enhance their professional business contribution for better quality of life in a fast-changing world. And I'd like to acknowledge 2021, 2022 PSC team. I'm currently the president of PSC, and Vice President Karen Liu and second Vice President Kevin Zhang. They're both on co-host list today. And we have Treasurer Genzhao Zhang and Secretary Hao Song. We are really a volunteer-based organization, so we like to acknowledge all the committee members and also past PSC presidents. Before I go, I also like to show appreciation to our generous donors to PSC. We are a nonprofit organization, and with generous donors from these companies, we are able to hold these workshops, such as the annual workshops and today technical workshops, to share with our community and members. So thank you again. Before I dive into LIDAR, I dig into the history a little bit. Actually, laser was invented, actually demonstrated 1960. So this is really good 61 years ago by Mayman. And obviously, this is really one of the major cornerstone of our industry, right? Without laser, we really can't talk about LIDAR. And as a matter of fact, 1 year after that, Hughes actually led by Malcolm Stitch actually demonstrated the first LIDAR. They call that co-LIDAR because it's called coherent light detection and ranging. So whatever we talk about in the last 60 years owing to these great inventions. So I just like to mention it. And then talking about today, right? 2021, 60 years later, we are witnessing a booming development in the LIDAR field. And recently, we just saw quite a few LIDAR companies went IPO. And here I compile public records from these 8 companies actually went IPO in the last, I would say, year and a half. Owing to the public record, that they all show their projections of revenue. So you can see there's really very bullish projected revenues coming from these companies. Actually, several of them on the panel today. So we'd love to hear how they're contributing to this booming field of LIDAR, shaping up the future here. In general, there are actually several big application areas, but we'd love to hear what they have to share today, including in the autonomous vehicle field, but also other emerging new markets as well for LIDAR sensors. And today, we are pleased to be able to assemble a esteemed panelist here. Dr. Jun Pei, founder CEO from Cepton, Dr. Ben Hua, a VP component from Aeye, Nan Luo, system architect from Continental LIDAR, and Dr. Yimin Li, founder CTO from Innovusion, Dr. Cheng Li, founder and CEO from VisionIC, and Dr. Tuo Shi, founder and CEO from ZVision. Without further ado, I'd like to introduce our first panel speaker, Dr. Jun Pei. Dr. Jun Pei is the founder and CEO of Cepton. He is a serial entrepreneur and technologist in optics and electronics. He developed the first optical acoustical combination technique in semiconductor thin film measurement, holds numerous patents in the field of metrology. Before co-founding Cepton, Dr. Pei founded AEP technology to develop advanced 3D instruments, and pioneer parallel computing in interference microscopy. Earlier in his career, he worked as a senior scientist at KOA Tencor in optics equipment, and also led engineering team at Velodyne in advancing the HDL64 LiDAR. Dr. Pei received his PhD in electrical engineering from Stanford University. So please join me welcoming Dr. Jun Pei as our first panel speaker.
Thank you so much, Ryan. Appreciate the introduction. Good morning, good evening, wherever you are. It's really quite an honor to be invited to this forum. So today I'm going to talk about the mainly LiDAR of Cepton Technologies. We're actually just among this crowd of people. Actually, again, very much honored to be one of the members here talking about a LiDAR technology, a LiDAR company that actually proliferated into this very new market field. And I might be preaching to the choir a little bit here, but still, you know, with the LiDAR that really started to proliferate. The market is either in automotive or in smart infrastructure. Is auto or non-auto. These are the market that occupies all of our attention. But for Cepton Technologies, as a company, when we started, we basically focused all of our attention in this area, which was not quite popular back then in 2016 when we founded. It was very much of an understated market space that nowadays is really has a lot of speaking power. I don't necessarily have to justify that ADAS is really the biggest market for LiDAR nowadays, just by looking at all these numbers. If you look at the TAM in here, by 2025, 2030, by our estimate, the $40–50 billion of total addressable market really speaks for itself. These actually far exceeds even the autonomous vehicle or infrastructure type of opportunities for LiDAR. And that's where we actually chose to concentrate our effort on. As I've mentioned, it wasn't the level 4, level 5 vehicles, which, you know, as a fairly mature and old engineer, I actually didn't see that happen anytime soon 5 years ago, and it's still not happening anytime soon, even as of now. So we put our bet into L2 plus ADAS applications, and that's actually the focus and the thesis of Cepton Technologies from the very beginning, and we never deviated away from that. All the subsequent, whether it's the invention of MMT LiDAR or actually the commercial engagement, all focused on towards that direction. So it's I guess as many companies, that this is one company that started with a market focus, and all the technical development, innovation, and resource allocation, investment, partnership, all of these subsequent activities came from that market focus. So this is, after all, a technical forum. So I have to talk a little bit about technology that Cepton is actually using for us and making a LiDAR. Again, I'm preaching to the choir in this forum, but still allow me to say that we have chosen 905 as our working wavelengths. We have chosen time of flight, that the thing that invented you know, more than half a century ago, as our measurement modality. These are the things that we really consider that has been invented well over decades ago, that you know, for example, the laser is already automotive grade, and they're, you know, a few dollars a piece or $1 a piece. Time of flight is such a mature technology, everybody knows about that. So what we did is we put all of the concentration resources in working on a scanning mechanism, what we call MMT, micro motion technology. That's where Cepton technology came from. That's where we shine. And in fact, all of these effort we did is to actually coming up with an efficient and simple imaging technology that really propelled our LiDAR to capture a lot of the achievement later on. I'll just do a quick word. So we also developed our own ASIC chip, as many companies do in these days. Low cost electronics is a huge advantage in our competitive wins. But after all, after 5 years into this very hot, almost a melting pot of LiDAR competitive landscape, it is no longer the technology that has the speaking power. I can pound my chest and tell you guys all I want, how great of technology we have invented, this or that. It doesn't really matter. This day is actually the commercial success. It's the commercial success, the design wins that get you the final validation of the technology. It's not talking about technology itself. It's really the business engagement and what kind of commercial attractions, what kind of design wins you have. And for us, even from the beginning, we didn't deviate from our focus. All these OEM engagement are really our focus in trying to get into the level 2+. And of course, the auto OEM B is the I can proudly say that's General Motors. Cepton Technologies, if there's any takeaway for today's conversation here, is actually Cepton Technologies has the largest design win in the ADAS industry for LiDAR. And that is actually starting from 2023. It's going to start with three platforms on 4 models. GM is a conglomerate of multiple models and multiple platforms, and adding on additional 4 models in 2024 with additional 4 models in 2025. These are not models replacing the previous year, but just addition. So by 2025, we're going to have a dozen models of GM cars with Cepton LiDAR installed in them. So this biggest design win is not only a validation for Cepton's LiDAR. It's really a validation for the entire LiDAR industry, everybody here included. This is, after all, finally a place that LiDAR is becoming mainstream. So we didn't come to this place, with this notable design win, the biggest design win in this industry, all of a sudden in an overnight sensation. Actually, this is actually just a quick snapshot of the history that we started. And the first engagement with GM was actually in September of 2017. And until the day we actually were awarded the contract in December of 2019, this is more than 2 years of a very long process. And at the beginning, we were competing with 30, 40 LiDAR companies. At the end, we're competing with just a very small handful, including some of the participants here. And eventually, we were awarded this program, again, December 2019. That's almost 2 years ago. We kind of buried our head and hid this secret very well for the past almost 2 years, and working on the execution of the program. Like I mentioned a little earlier, this design win was actually meant to be SOP, start of production, in 2023. And we started well over 2 years ago. We're actually, let me see, we're right at this point. So as you can see from this chart, we're actually delivering C samples, getting into ready for the PPAP. So right now, it's really just a clear shot for Koito to beef up their production line and start to crank out. I'll use a GM's term, we'll start to print out these LiDARs from their production line. So I guess I'll skip this slide just for the sake of time. That it's important to have a tier 1 for anybody working in the auto industry. I have certainly learned that try not to be a tier 1 company, just even from the liability perspective. But skipping this slide, Cepton Technologies certainly now have a solid place in LiDAR hardware platform. We are also very active in creating the automotive software as well as the perception software that associate with our platform. After all, our company, Cepton, is just letting you know, the name itself, CEPT, is actually a borrowed part from the word perception, and OM being the Latin ending of an element. You see photon, electron, atom. So cepton really means a element of perception. So we're certainly not going to forget there's a huge software element of the perception. Indeed, that's what we actually already have started working both on the auto and non-auto portion. And this is actually a very much of an example for a non-auto application. Cepton LiDAR and perception was chosen for a monitoring system at Orlando International Airport. This is a big international airport. At this terminal, 7 LiDARs, Cepton LiDAR, were installed to actually replace 24 of their existing cameras together with our Helios perception software. And I'm sure you're going to ask a question of what do you use the LiDAR for? Well, it actually turns this international terminal into a smart terminal in a smart space. You look at the upper left of this display, you see all these people that's moving around the terminal is actually being monitored and tracked by our LiDAR and the associated software. But then you ask, why are you tracking these people other than look at all these little things looking like small ants? Well, you only need to actually put a time-elapsed video using the data you've gotten, and suddenly, aha, this is how the terminal is being used. You immediately realize how you can optimize it, or simply send the cleaning crew to the strategic location to save some janitorial costs. So all these are very, very valuable information that at this terminal, Cepton LiDAR and its perception software is capable of delivering. Well, in this kind of unfortunate day and age that we have the social distancing need, it is just a switch of the software configuration to turn this place actually into a social distancing monitor. Indeed, this terminal, based on our software, they installed these light towers indicating, okay, these are the green zones, and I see a yellow zone over here. I see a red somewhere, I almost see a red over there. But anyway, this is how it's actually being utilized live at the Orlando International Airport. So that brings some interesting applications for our LiDAR. Hopefully that's also interesting to you, and that brings to the end of my presentation. I'm sure you're going to have a lot of questions. Later on, we have a session to kick the tires.
Thank you so much, Dr. Pei. Okay, great. So we're going to bring up our next speaker, Dr. Ben Hua, a VP component from Aeye. Dr. Hua has 30 years of corporate management and optical industry experience in Silicon Valley and internationally, managing corporate product strategies, new product platform from R&D to mass production. His career spans roles in global marketing, corporate R&D, and product line management at companies including ONET Technologies, JDSU, and eTech. Ben holds a PhD in optics from SITU and postdoctoral fellowship from NSERC. So please join me welcoming Dr. Ben Hua.
Thank you, Juan. Good evening and good morning in China. Thanks PSC and thanks the organizer, Dr. Luan, Kevin, Karen, David, and others for organizing this workshop. Today, I'm going to present a high-performance adaptive 1550 nanometer LiDAR system made by Aeye. Next. As you have read many news articles, LiDAR will be everywhere. So today, most attractive potential market is automotive industry, which has a huge potential market for LiDAR system to grow the business. ADAS from level 2, level 3 to level 4 and 5 is a path for self-driving cars with LiDAR systems. In addition, there are many use cases across numerous large addressable markets in other industrial and mobility sectors, such as tracking, mining, shuttles, delivery, traffic system, railroad system, aviation, and drones. Next. So here, I would like to give a brief introduction of AI system. It's a design element. The concept is using modular and adaptive. So first portion is an optical scanner system and the receiver. And it is designed not coaxial. So the scanner is more agile in controlling the laser beam to where it wanted and at different laser peak power, also the scanning speed. While the receiver, just like a camera, a traditional receiver, 2D receiver to capture whatever the field being illuminated by laser pulses. The controlling system is designed in a system on chip kind of concept, embedded with artificial intelligence, with different custom design use cases. The software is also modular and standalone, so you can plug in for different customer applications. Next page. So one of the unique features is we are using 1550 nanometer fiber laser, which is eye safe and also can provide several kilowatts peak power, which is has advantage of high peak power over 900 nanometer laser, which is limited by eye safety. In addition, nowadays the fiber laser are qualifiable in automobile grade operation temperature and also other related shock vibration tough environment. Another feature of our design is we're using MEMS scanner. The MEMS scanner provides agile scanning capability. You can either scan the whole field of view, or you can only scan very small sector of the interesting subjects with a much high density to identify distant objects. Later on, we'll show you the examples. In addition to that, we have very good receiver module which can detect the signals from 1 centimeter to 1,000 meter. And also each pixel in the receiver array is independent or isolated. So with very good signal to noise ratio and also very good quality of point cloud data. Of course, like everybody in this industry, we are doing system on chip design and embedded a lot of AI custom design software. Next. So our LiDAR system is built on an intelligent detection and ranging system platform. We call it IDA. So it has a feature searching everywhere and revisit the critical objects, then acquire targets, then tracking. Let me using plain language to explain to you. Say, for example, in the first frame, you have a very rough intensity and also resolution. To quickly check the front of your car, you found a suspicious animal. Then the scanner will adjust the scanning beam, focusing onto this animal, deer, just like a human eye, right? You saw something, you want to stare at it. Then if the object is in distant or in close by, you can adjust the laser intensity to make sure proper illumination of the objects. Then you acquire a very clear image file with very high density point cloud data. The next one is using software to tracking the interesting subjects. So in this way, the scanning is not like randomly, it's on purpose. For example, the motorcycle on the road, you can quickly identify this critical piece. Or in the undivided two-way street, you can watch the incoming car to give yourself a warning and to avoid collision and all possible incidents if some animal cross out. So in short, this one, we tell you we have unique intelligent detection and ranging feature. We can adjust the scanning targets, area, density, and detecting signal intensity. So to obtain best quality of point cloud data. Next. Here is another example of solving most difficult industry challenges, like the kids, crossing the road when the car is in the stop sign. So this detection also very fast, agile, and try to use the scenario cases. When the car in stop, you trigger that mode. So watch out this pedestrian. And also, you may check our website. We are capable to detect brakes scattered on the road, those small objects with very low reflectivity. So we can adjust the laser beam intensity and also scanning range to identify this particular subject with unique scanning pattern. Same thing, we are partnered with a truck company to do self-driving truck, which require very long distance brake requirement. So that's why we are working on 1,000 meter detection capabilities. So this system are adaptive to multiple different scenario of applications, from the self-driving car, truck, intelligent traffic system, and also other military applications. Next. As all the panelists here, most of us are startup small companies. We are mainly focusing on making sensor because LiDAR only a sensor. I think except the partner Continental speaker, they are tier 1. So we are right now publicly announced Aeye and the Continental are forming a long-term strategic partner to launch 1550 LiDAR in 2024 in varieties of OEM put on the car, such like a Mercedes-Benz, Audi, or some other cars. So why we selected the tier 1 as a partner? As you know, the company like Aeye and some other LiDAR company, we are small startup. We only make sensor element. It's part of critical element for the whole self-driving system. And we needed to partner with the tier 1 to help utilize their resource to help us to penetrate the market. For example, Continental, they already is an ADAS supply to 25 OEMs with 50 brands and 300 models of cars. From 2027 to 19, they already shipped 100 million ADAS units. These parts, including radar, camera, LiDAR, and ADCUs. Their 2019 revenue is already over 44.5 billion and 250,000 employees. And more importantly, their presence is over 595 locations in 59 countries. So this is a valuable asset to help this new technology penetrate into markets. That's why we selected this business model, and we are in the good progress towards that goal. in the center is the HRL131 LiDAR. This is the form factor which will be front mounted in the car to be launched in year 2024. And before my presentation closure, I would like to show you a video clip to show AR LiDAR system has achieved 1,000 meter range in rain or behind the windshield glass. Thank you for your attention. Ryan, would you please run the video?
Got a car at 1,005 meters, and we're going to go ahead and add a second car with a different dimension to it to get a feel for how many detections we get on each of the two different cars. And we're also going to add this water truck here, and this water truck is going to spray in the middle of the environment. That will allow us to show we're shooting both through a windshield, through the water, and still seeing two different cars of different shapes and sizes at a little over 1,000 meters.
Yeah, thank you.
Great, that's a good show. Thank you, Ben. Okay, thank you, Ben. Let me bring up our next speaker, Nan Luo. We're talking about Continental. So Nan Luo actually is a system architect for LIDAR division of Continental. And Nan taught laser and optoelectronics in college for 4 years before joining Nokia. He worked with several high-tech startups in senior technical and management roles to drive concept, prototype design, testing, reliability, to mass production for various advanced photonics and fiber optical telecommunication products. Nan has over 20 years created multidisciplinary engineering experiences in optics, mechanics, electronics, computer, hardware, software fields. Nan is a member of SPIE, published multiple papers, and holds multiple patents. He received a master's degree in optical engineering from Xi'an University Science Technology in China, and another master's degree from electrical engineering in University of Texas at Dallas. So please join me welcoming Nan Luo.
So good evening and good morning in China. Thanks everybody for joining. I think my topic here will be basically that I'm going to share my little bit of experience or lessons there when we Continental developed a flash LiDAR basically from a prototype to an automotive grade. So for this journey, I think there are quite of interesting things to be shared, but here I just give some brief introduction here. Okay. So actually, this journey starts, basically starting point is that it's 1987. So we can say almost 30 years ago, there's a company called Advanced Scientific Concepts. So this company is founded by a PhD, and basically he's focused on the flash LiDAR development, mainly focused on the military space or navigation, this kind of area. So you can see here are two projects that have been done previously. You can see the first one, basically use their LiDAR that has been mounted on a spacecraft to use that to docking of the spacecraft to the space station. So this has been used on the Boeing's project. You can see from this middle, the first one is their camera. The second one is that's spacecraft, you can see that approaching the space station. So the distance there basically is measured by this flash LiDAR. The third one you can see that's a point clouds of this LiDAR. So another project also is pretty interesting is that basically it's a NASA project. So basically NASA's mission is trying to launch spacecraft that going to reach asteroid. That's called a name actually is called a Bennu. So trying to reach that asteroid and trying to grab some rocks there as sample to do some research. So this project actually has been signed, you can say pretty early, 2012. And this flash LiDAR has to be installed on this spacecraft and travel about 4 years to reach that asteroid. So you can see, so the reliability here is very important for this flash LiDAR, right? So you have to be sleeping over 4 years, then start to work. So you can see these two pictures here. The first one is then when year 2020, this spacecraft reached this asteroid. So you can see that robotic hand basically approach the Bennu. And the second one, you can see that connector basically sampling the rocks from the Bennu. So this distance also is actually measured by this flash LiDAR. Yeah. So at the year 2016, the one division, so because LiDAR is more towards to the automobile industry, right? So at year 2016, so there one of the division called the ASCA, basically acquired by Continental Automotive Group. I think Continental is a tier 1 automotive supplier, right? Over 20 years experience. They have made like 3-point LiDAR and they used to involve and for almost 20 years ago. So that's their experience there. So the new mission is that when Continental acquired this small startup, so the new mission is they're trying to commercialize of this flash LiDAR for autonomous driving. So that's their goal. So then based on the automotive grade, right? So there will be a target state. So what kind of range needs to be reached? What kind of field of view and a frame rate, and also spatial resolution of the LiDAR has to be defined. Also, the critical one is the operational temperatures, right? You have to go very low and let's say from -40 to up to high to 85, maybe even to 100 degrees. So you can see this is the A sample that's originally developed from the ASC. So I just kind of gave a little bit of, advantage here for the flash LiDAR. So you can see, so the principle is still the same, like, based on the time of flight, right, QF. And if you look at this picture here, this one is a scanning LiDAR, one is flash LiDAR, right? So we can say flash LiDAR basically just illuminate the field instantaneous. So, which means even the object is moving, so you won't see that kind of motion cause the distortion, right? But for scanning one, you will see that distortion caused by this moving project or moving objects. So this is one of the advantages of the flash LiDAR. Also, flash LiDAR can have much higher frame rate because it's not like scanning. They don't need much time there to do the whole field scans, just one shot. So they can have very high frame rate. Also, because it's a solid state, right? There's no moving parts, no scanning of the beam. So That means there is no wear out, so it means longer lifetime. Also, it's anti-vibration and the shock resistance, right? Due to the same reason of there's no moving parts. But the drawback of that, I think, is shorter range, because the flash light, you cannot really reach very far. So the range typically is a shorter range. Also, because your receiving side, it's a two-dimensional array, so that typically involved with a high cost of the receiver side. But you can see flash LiDAR, the principle is very similar like our camera, right? So you flash out a light, then you get a two-dimensional array to receiving the whole image instantaneous. So this here, you can see here is one of the application for automotive LiDAR. So typically automotive LiDAR is divided into a short, mid, and long range of kind of three categories here. So here, the first graph here showing basically the truck here in the middle. Now you can see there could be 6 to 7 LiDARs installed. One is for long range, cover small field of view. And also there's a mid range of LiDAR, then plus 2 surrounding LiDAR, which cover much wider angle field of view, up to like a 120 degree. Then there could be 2 or 3 short range LiDAR that covers the rear side of the truck. So this is kind of one of the typical application for the truck. But also, you know that the Mobileye, right? They are right now building their robot taxi. Actually, they have been installed 9 LiDARs in this, robot taxi. Actually, Doctor, you asked me to compare the automotive requirements versus telecom. I think this is definitely an interesting topic here, because I know 1/3 of the LiDAR company actually came from the telecom industry. So they know transmitter or receiver very well. But for automotive, I think the major difference is that you have transmitter, receiver, but you also have this field of view, means you have to have a scanning beam, or you have to have a beam steering kind of methodology. So that's a major difference. Then there will be a definite performance side comparison here. So I'm just pointing out here for the temperature range. Like for telecom, typically you go to from -40 to 85 degrees C. But for automotive grade, typically they ask the same, or could it be even higher? Like in some applications, they're asking for a 100 or 105 degree, this kind of situation. So also they asking for the shock vibration, resistance, right? Typically there will be a testing from 5 to 2 kilohertz sweeping, which means if you use a MEMS scanning, so your mirror has to be get your resonant frequencies out of this range. Otherwise, it's kind of hard for you to pass this test. So this is one of the actually this is one of the advantages that Ben just mentioned that for AI, I think this is their MEMS mirror is really kind of outside of this range. Yeah. Also, it will be cost target, right? So right now, so the whole industry is trying to make the LiDAR below $1,000 in mass production. So people are also talking about like $100, but that could be still a little bit far away, or could be 5 or even more years, to come, I think. So this journey, like we are going to talk about, is we have this process from A sample, then go to B sample, then after B sample, we go to the design verification, then go C sample, that's finally get production validation here. So then finally go to SOP. So I'm just give you a very quick brief introduction here. How do we get to final SOP? So from A to B, we found that our camera, our LiDAR actually cannot go very high temperature as our customer required. So what we did is like this. So this is our original A sample camera. So we splitting that into this is our B sample. You can see much smaller. But what we did is we moved out our processing chip into another unit called an electronics communication unit. So we moved some heat source from the A sample into another unit. So that makes this B sample to be able to working at very high temperatures, which is customer required. Then from B sample iterations, right, we have a design verification validation here. So from this process, we found that we have contamination on our diffuser, and also we find the sealant outgassing, this kind of issue there. So which spent us a few weeks delay, and plus additionally R&D cost. Actually, is probably more than a few months of this cost.
Hey, Nan, sorry to interrupt.
Okay.
On my clock, you got about less than a minute.
Oh, really? Okay.
Try to speed up. Thank
okay,
you.
sure. So, okay. I'm going to skip this little bit. Okay, so the lesson I think we have learned is that when we go this, we call the V model development cycle, right? So you go from customer requirements to system spec, then high level design, then detailed design, then go to implementation, then go to the backwards to unit testing, subsystem testing, system testing, to finally get customer acceptance testing. So most of the time, I think people only look into this path, but really you have to be focused is look at this horizontal path. So horizontal path means when you think about customer requirements, you have to think about how do you do a testing to validate this system. Also the same is here. When you do the system specification, you need to think about how to do system testing. And the same way is when you do the detailed design, you have to think about how the testing is going to be. Let's say, very simple example, like we mentioned that when you design the MEMS mirror, you have to think about when you do this testing, you need to somehow testing this from 5 Hertz to 2 kilohertz. So when you design, you have to think about how to avoid the design to have your mirrors resonant at this region, right? So that's kind of a lesson we have learned, yeah. Okay, so this journey, I mean, finally we get into the SOP, and our successful ending is that this 3 short-range LiDAR has been installed on the next Toyota Nexus LS, and also another model is Mirai. So this 3 LiDAR is basically, you can see on each side of the Nexus, and also one on the rear side. So this 3 short-range LiDAR basically cover the back field of view of this car, and there is another one, a long-range one in the front. So yeah. So basically, I'm going to ending my talk here. The main lesson, like we just the lesson we have learned is that we really have to follow this V model, and we also have to think about that horizontal way. When you start to design your product, you have to think about the testing side, and the design engineers have to understand the testing and the reliability requirements. So that will help a lot for speeding up this production cycles. Okay, that's ending my talk here. Thank you.
Thank you, Nan. Yeah, thank you, Nan. Let's bring up our next speaker, Dr. Yimin Li, founder CTO from Innovusion. Yimin has 20+ years of experience with electronics, optics, laser technology, including LIDAR sensors. He was tech lead at Velodyne LIDAR and managed tech projects at Baidu, Agilent, AOSense, and GE Health before co-found Innovusion in 2016. Yimin received both BS and PhD from Peking University. Please join me to welcome Dr. Yimin Li. Yimin, you're up.
Okay, thank you, Ryan, for the opportunity. And hello, everyone. It's my pleasure to share some of my experience with everyone here on our LiDAR journey. So basically, we develop a 1550 DTOF LiDAR, and we try to push its application as much as possible. So next slide, right? So here is a brief history of our company. We were incorporated in 2016, and ever from there, we start develop this 1550 LiDAR. And we released our first product called Cheetah in 2017, and we keep evolving the product. And right now it became the family of Jaguar. Most of them are in the application, V2X application, basically the smart infrastructure, smart city, smart highway application. We have our biggest customer, Baidu, on this front. And from the year 2018, we start develop another family called Falcon. After 3 years hard work, at the beginning of this year, basically January 9th, we were nominated by NIO to be a partner to equip our LiDAR on their vehicle, the ET7. This is a target pre-installation. Basically, every NIO ET7 will equip one Falcon LiDAR when it was out of the factory. And you can see we got a lot of intention this year. We received 3 rounds of funding already. And we are also, with the help of the investor, and we are speed up our development with NIO. So right, next slide. So the company, we have basically we have 2 founders. Basically, Jun Pei is the driving force. And I was honored to be joining his journey at the same time. Back in 2016, we were both working at the Baidu autonomous driving division. And at that time, we feel the LiDAR will be a must for autonomous driving, but we don't think there is a good LiDAR out there. So we feel the urgency to develop some reasonably good LiDAR. So we coming out in Baidu and start this is a roller coaster type of journey. And so far, I think we're in good shape. So next slide, right? So I just want to explain a little bit why we are choosing our configuration. From this slide, basically you can see there are some popular scanning mechanisms. And each scanning mechanism, there a backer. So basically, we have lots of different player in this field, and everybody try to push hard for their solution, including us. And I think right now the most popular LiDAR scanning type can fall into 3 categories. The most popular right now is the semi-solid state. there are a few subfield on the scanning mechanism, and we are one of these. And we believe our scanning mechanism has some advantage here. Basically, I think the Gavo plus rotating mirror is very old technology, but we thought it's the most reliable solution so far, and its method can be volume production, can be built very cheap. So that's our pursuit since day one. And I'm not saying the other solution may not have a chance, but I'm not the judge. I think market will give out the final answers. I believe in the next 5 years, we will see the consolidation of different technology, and I think given another 5 years, we will see the consolidation in the organization. So, but one thing I think that we at day one we don't start with the mechanical because we don't think that that solution will be eventually on the final shape. So at the very beginning, we'll abandon the pure 360 solution. Although we spent some time in America and developed the HDL LIDAR, so we know that one pretty much. But I personally don't think that one is the final solution. Will be an intermediate stage. It will mark its position in the history, but I think it's time for them to phase out. Yeah. So next slide, right? So I think for LiDAR, it's the application depends the solution or the technology you apply. We divided it simply two categories. One is for this long range, for the autonomous driving application. We believe if you want to be safe enough, at least a 200-meter reasonable resolution and field of view. So per that perspective, we believe 1550 is the only solution. And also, we don't think that's the only application of LiDAR. If you want some like a vehicle blind spot, just like Nan mentioned, you have some short range or some middle range. I think nanofiber is still an alternative in economic and power consumption and the size point of view. So I don't think we are directly compete with each other because we are targeting a different application and different market. So at this moment, we focus on 1550. And why we choose 1550, I think Ben explained a lot. So basically, there are higher eye safety limit and better linear APD, so it has a adaptive dynamic range. And we use full wave analysis, so we can handle more complicated situation. And the only difference I think between us and the Ben is the scanning mechanism. We think the MEMS is too difficult. So we admire the people with a lot of capability. So they are brave enough to challenge the MEMS. So we just rely on this very old technology, less risky. So we think that that's the quickest way to be mass product the LiDAR. So next slide, right? So here is a landmark. So where we are. So to be honest, I have each target competitor, and when I look at the name, I thought I better hide them because I don't want any argument on this workshop. So I just want to present what we are doing and what we thought. And so basically, we believe 1550 is the ultimate solution, but I agree there are lots of challenges, say like non-auto-grade parts, the expensive parts, but we believe those issues can be solvable. a given time, so say, so maybe 1 year, 2 year, we can achieve the low cost, high reliability. That's not the fundamental limit. But I think that it's very difficult for most of the people. I think actually it's a good thing. The difficulty is a barrier for other people. It's not for us. We have the confidence here. So yeah, next slide. Yeah, basically here is the what we have today. We present to the general audience and the general public. Basically, this is a so-called Falcon LiDAR. We call it a Falcon Kinetic. This one is available to anybody. Our partner NIO is very generous. They said you cannot disclose the industry design of their LiDAR. This one is different from 87 LiDAR, but in performance-wise, they are the same. So we are very glad to have this very generous friend and our big supporter. And you can see the performance. I believe this one is a leading spec for the long-range LiDAR. So I think that's pretty much where we are today. And we have a small number of samples for people to evaluate. The majority of production is reserved for NIO. So we are cranking hundreds of units per week. So at this time. So next slide. So here is some show. I believe it's a show time. So we have some videos just show the superior performance. And for this one, Rang, can you replay? Yes. Basically, you can see the lettering from the vehicle, and also you can see the small box from very far end. So, and this one is a big differentiator. Lots of people, when they see this one, they are surprised and they kind of astonished. So, and there is another video side by side to this one. I'm afraid to show because that's the competitors' performance. Basically, they cannot see anything beyond 100 meters. So they don't even have good resolution. So this is the lettering. And next one, please, right? So basically, this is the demonstration of the pedestrian at 125 meters. So yeah, you can play the video. You can see it's very, very recognizable. It's a person, and also you can distinguish the legs and also the movement. This is very, very useful and enrich the information for perception. And that's why we emphasize only long range is not enough. The high resolution is a must associated with this long range. So nowadays people are talking about I can see 200 meters too, but without the high resolution, the 200 meters doesn't mean much. And in another word, also for 200 meters, there is another differentiator called POD, or probability of detectivity. And yeah, you can see something, but how reliable you can see the target. That's the differentiator. So we emphasize on that one. So we claim 250, 10% inversion technique, but we also promote we are at a POD of 90%. So that 90% to 50% is a huge difference. Some factor of 6 in between. So that's we have high confidence over LiDAR performance. So next slide, right?
You mean you got 2 more minutes?
Oh, I run that part. Oh, sorry, I need to speed up. I think, but somehow I think I present a majority of the content I want to present. And Rang, can you replay the video? And this is a side to side, so I think we are safe. The competitor is not here today, so it's safe to play this video. And you can see the field of view is very different. We are unique, and our competitor is combined. So basically, the field of view is not continuous. And also the ground, you can see we have ground return up to 120 meters. This is very, very important to our neighbors. So they emphasize this number. So next slide, right? Yeah. So basically, this is a test within our pseudo office. So you can see the lady is picking up the small target. So it's very, very distinguishable. Yeah, so maybe I need to speed up. So then maybe next slide. Yeah. I think that's all the showtime and entertainment for everybody here. And beyond the hardware, we do have a software team, very big software team in Shanghai. So we are also hiring. So there are lots of openings. So anybody have interest to work with us, to go through the same journey with us, you are welcome. And we have another big office in Shanghai. It's opening. So we have a very good opportunity for everybody who will appreciate our effort, who will like our solution. You are welcome. So next slide, right? Basically, this is the quality. I agree with Nan and Ben and Jun Pei. All the easiest part I already finished the presentation in my presentation. This is really, really hard part. Before that, I think before work with NEO, we don't know autograde mean. To be very honest. But after working with NEO, we really understand, and I think we are close to the final mass production. I have to be keep it a secret where we are, but what I can say, we are very close because Li Bin announced the next Q1 will be their ET7 release date. So we will have to work very hard. And for NEO, I think for a LiDAR company, if you like the LiDAR company, you let them work with NEO. And if you hate a LiDAR company, you also let them work with NEO. So it's very, very polarized condition, but we really enjoy it. So now we have the confidence when we face other customer or tier 1 OEM say, we really know what autograde means. Yeah. Next slide. Yeah, basically here is I think I don't want to go too deeper on this one because I think Nan, Ben and other panelists here, they know it very well. And also for the qualification, we have a very, very solid qualification in our current factory. So we are very confident on the quality. So that's why we feel it's not a big deal. Here is our partner ecosystem. So basically you can see there are lots of big players here, and we increase the list every day. Yeah. So basically that's all I will conclude my presentation here. Thanks everybody.
Yeah, thanks so much, Yimin. Let's join me to welcome Dr. Cheng Li, founder CEO of VisionIC. Dr. Li founded VisionIC in 2017. From 2013 to 2017, he was a senior research scientist with HP, design high-speed optical transceiver circuits, photonic interconnects, high-performance computing, LiDAR image sensing systems. From 2001 to 2007, he was with Alcatel-Lucent, where he developed broadband DSLAM 7300 access system. He has authored more than 100 papers, more than 20 US patents, has been a member of technical program committee of IEEE Compound CF Semiconductor IC Symposium, IEEE 58th Midwest Symposium on Circuits and Systems, KTMA member of American Institute for Manufacturing, AIM. Cheng Li received BS degree in electrical engineering from Southwest University in China, MS degree in computer engineering from Illinois Institute of Technology, and PhD in electrical engineering from Texas A&M University. So please join me welcoming Dr. Cheng Li. Let me stop share, and Chen, you can take over.
Cool. Okay. Right. Thank you for your introduction. Today, my topic today is a monolithic SPAD DTOF sensor for the solid-state LiDAR. So in VisionIC, we always believe the optical device and the integrated circuits and other key components are the key to drive the evolution of the solid-state LiDAR. So I'm a little bit different today as a topic of the other speakers because I'm specializing in the IC design, not in the LiDAR system. So VisionIC was founded in 2016. Our mission is to let the machine sense the world in an easy way by providing a 3D IC solutions for consumer electronics, security, and the automotive industry. We total have 120 employees with 75% are R&D. Headquarters is located at Nanjing, China, and with research center at Silicon Valley and Shanghai, and also the marketing center at Shenzhen. So this slide lists 3 major 3D techniques, which are structured light on the most left, and the indirect time of flight listed in the middle, and the direct time of flight listed on the right. So for the structured light, it captures target pixel position on the image sensor. Then we use triangulation to calculate target depth information. Great computation power is needed actually to construct the entire 3D image. But more importantly, the depth accuracy decreases sharply along the detection range. So it's suitable for some short range applications, such as the everybody knows that iPhone used for the Face ID. So at the indirect time of flight, the laser shooting out a white pulse or a continuous wave, and the receiver sensor ratio of the object distance to the modulated laser period. So iToF normally use the CMOS image pixel as a sensor element, so which can then reach the VGA resolution. The entire IC architecture, is similar as the CMOS image sensors. However, the major drawback is relative high power consumption and also the multi-pass interference effects. So some of the Android phones use iToF as Face ID, but since it's short amount of working time, for example, such as 1 millisecond, won't burn a lot of power. But however, it won't be a different power story for the AR/VR applications since the sensor is always on. So direct time of flight, as all previous specialists has mentioned, is pretty straightforward. So the round trip time of the laser pulse divided by 2 times the light speed give out the object distance. So the major distance is longer, the power is lower compared to the iToF. So that's the reason that most vehicle LiDAR now are using the DTOF technology. But however, design challenges still remains, such as the pixel resolution and also the entire chip architecture and also the silicon process maturity. So most of DTOF on the market use APD as a photo detector. APD works below the breakdown voltage in the linear mode. Its sensitivity is about microwatts level. However, largely analog circuits make the monolithic integration is very challenging. Instead, SPAD, which is single photon avalanche diode, works above the breakdown voltage in the Geiger mode. It has a sensitivity of few photons, so which gives the system a very high sensitivity. But most importantly, the following digital circuits show small footprints, make it easier to integrate SPAD with the logic circuits monolithically in one die. So the key specs of the SPAD is PDE, which is photon detect efficiency. For current CMOS technology, the silicon SPAD could achieve 20% PDE at a 940 nanometer wavelengths. So there are a wide range of applications for the DTOF, not just the limited as vehicle LiDAR. So for the mobile, each phone could equip with a 1 DTOF sensor in its Face ID, such as Apple's iPhone, and the high-end Android phone uses for the laser focusing for the back camera. Since 2019, everybody knows that Apple used iPad Pro first equipped DTOF sensor as the back camera, called the LIDAR scanner. Then we see iPhone 12, the 13, both equipped with a DTOF-based LIDAR scanner. So for the self-driving car, SPAD DTOF is becoming a promising solution. Sony just released a SPAD DTOF depth sensor for the self-driving LiDAR solutions this year. So LiDAR startup Ouster acquired SiFotonics to accelerate the LiDAR development progress. Both of them, focus on the SPAD DTOF techniques before merging. Besides the mobile and autonomous driving, DTOF could also be used for many other applications, such as SLAM for HEV and the sweep robots. So in the future, we will see AR/VR goggle use a DTOF sensor to sense the environment and recognize the gesture. So this slide shows Apple's LiDAR scanner. On the transmit side, it projects the 24 by 24 dots. And at the receiver side, the SPAD near-infrared CI sensor measures distance between the iPad and the 24 by 24 dots. The processor then creates a 3D map of the environment. So later this year, Sony released the SPAD DTOF depth sensor for the autonomous driving. It approximately has 100,000 SPAD pixels with 10 micrometer pixel pitch. It could support 3x3 binding mode. The PD is 24% at breakdown voltage about 20 volts. With the mechanical scanning and the sufficient laser power, it could reach 300 meters detection range. So after discussing the leading company progress on the SPAD DTOF sensor, now I would like to introduce VisionIC's SPAD DTOF products. So for 1D DTOF, 4300 is a long-range DTOF sensor with maximum distance of 50 meters for the SLAM application. 5300 is a short-range DTOF sensor, which could support 5 meters for the camera lasing distance auto-focusing. For 3D products, so VisionIC released 3 3D sensors with different resolutions. So they are based on the FSI process. The SPAD array and the back-end logic circuits are more or less integrated into one die. All depth process engine and the MIPI interface are included. So it outputs the 3D cloud points directly without the lead of the external imaging signal processor. So lastly, we're going to release our BSI 3D stacking DTOF sensor next year. So for the long-range DTOF sensor 4300, the longest range is about 50 meters with 100% accuracy. So depth resolution is about 1.5 centimeter with a maximum frame rate of 7.2 kilohertz. So this sensor more or less integrates the SPAD array, quenching reset, time to digital converts, histogram, algorithm, MCU, RAM, and also many interface into one die. Compared to the discrete APD-based DTOF solution, 4300 burns much less power with higher performance and low cost. So the SPAD PDP at the 905 nanometer is about 12%. So we are developing the next generation of 4300, try to reach 200 meters outdoor at 100 kilolux environment. So 4300 could be used for a variety of applications, such as LiDAR for vacuum robots, collision avoidance for the HEV, and the drones flying at fixed altitude, and also the laser distance measurements. So for the short range DTOF 5300, so the maximum range could support 4 meters. We see the blind zone is about 2.5 centimeter. Accuracy, we could achieve 4%. So the angle is about the 25 degree. The frame rate could support 90 hertz max. It's eye safety and the class 1. It's packaged in the SiP, and the with the VCSEL laser has been integrated. So it's pretty straightforward. It's actually just a chip module with a laser and with a receiver. So you just add some firmwares, then it works for you. So it could be used for the camera and projects the laser, distance autofocusing. It could be also use the collision avoidance, such as sweep robots along the wall. It could also be used for the perception, such as a screen wake up for the laptop and a smart door lock. So besides, it could also be used for many other applications, such as liquid level detection and some industry automation applications. So this slide shows the VisionIC 3D DTOF products. So we have the highest SPAD pixel resolution has been released on 2020. It's QVGA 320 by 240. The longest detection range is 15 meters, since it's designed for the consumer electronics, such as a phone application and also AR/VR. So we believe this range is good enough for this consumer electronics area. So the accuracy is 100% with depth resolution of 0.75 centimeter. It supports the max frame rate of 6 frames per second. So we also have another 4320 has been designed with a resolution ratio is 4:1. So a 256 by 64 SPAD pixel resolution. It supports longer, could support 30 meters with accuracy 1%, the same depth resolution, but supports much higher frame rate. So actually we are designing the much longer flash LiDAR, monolithic IC, for self-driving system. For example, it could support 50 to 100 meter detection range. So we also would like to work with other LiDAR company, see how VisionIC IC could provide support for their LiDAR solutions. Okay, that's all of my talk today, and thank you for listening. And if any questions, we can discuss on the Q&A windows. Thank you.
Thank you so much, Dr. Cheng Li. Okay, so yeah, thanks, Dr. Cheng Li. And let's bring up our next speaker, Dr. Tuo Shi, founder and CEO of ZVision. Dr. Shi co-founded ZVision Technology in 2017 and served as chairman and CEO. Prior to founding ZVision, Dr. Shi was the director of silicon photonics integration at SiFotonics and successfully developed the world's leading coherent receivers and germanium silicon APDs and other chips. Dr. Shi has more than 50 patents for integrated optoelectronics and LiDAR, including more than 20 US patents. Shi Tuo received his bachelor's and doctor's degree from Tsinghua University. Please join me in welcoming Dr. Tuo Shi. Shi Tuo.
Hello, hello everyone. Thanks for inviting and for the vision to have this chance to share our LiDAR development progress with everyone. Let me move on. Okay, LiDAR has been evolving since a long time, and Rang and some other presenters shared that LiDAR has been existed for like several of decades. And for the industrial application, LiDAR starts with the geographic test and industrial applications with one line. And in the last 20 years, LiDAR has been utilized for the robotaxi road test with mechanical spinning LiDAR, and with like starting from 4 lines, 8 lines to 16 and to 64. And right now, the mechanical LiDAR is going to 128. But in the 2018s, the autonomous driving applications has been booming, and a lot of the autonomous driving applications like a truck, like low-speed deliveries, ADAS applications, robotaxis, and roadside monitorings, and robots has been into mass production. And for these applications, the industrial will need more of the productionable and low cost, high performance, and higher reliability LiDAR solutions. So this LiDAR has been booming into all of kind of technologies and solutions. From the scanning method, there is mechanical spinning and the flash and MEMS, and also there's some other new methods coming up. And from the receiver side, we have the array receiving with CMOS and APD and SPAD receivers for the high performance, and also coherent receiving with frequency modulated continuous wavelight transmitters. So we believe that the different technologies and different solutions has different advantages. For mechanical spinning, the solution is very simple, and it's much easier to achieve high performance. And also this has been helping the industry moving from early stage lab level road tests to the industrial applications. And for the industry go up to hundreds of millions of LiDAR units shipping, the LiDAR will need more robust and high reliability, lower cost solution. So this is when the solid state LiDAR come up into the market, and the flash, MEMS, OPA are competing in the industry to bring the best solution. And from the vision side, we believe that the MEMS LiDAR will be the leading technology for the production in the next 10 years, because the MEMS LiDAR can also provide the higher performance with like 200 meters of receiving of detection, and higher reliability to over 40K hours of reliability and a lifetime, and a lower cost to hundreds of dollars, and a mass production with very high throughput. And the key challenges for the MEMS LiDAR, we believe that, is to achieve the 0.1 degree of resolution, and long range detection range of 200 meters, as well as auto-grade reliability simultaneously. So this has been bothering all of the other competitors in the industry. How can MEMS LiDAR be robust and high performance in the meantime? So ZVision has delivered the state-of-the-art solution, and well balanced the performance and the reliability of MEMS. And we already have passed the all kinds of qualification requirements for the MEMS LiDAR production, starting from like sweeping signal vibration from 10 Hertz to 1000 Hertz, random vibration, mechanical shock up to 50G for the passenger vehicles, 80G for the commercial vehicles for the module level, and for the component level, we have passed 1000G for the MEMS chip itself. So this has been proven very high reliability and robust production in our side. Also, we have tested the temperature cycling and the low temperature, high temperature performance. The MEM scanning variance is less than 0.1 degree of the angular resolution. So this has been very very qualified for the mass production for the next 10 years. And right now we are ongoing with the DV and the PV process, and the PV will tend to be achieved by end of this year. So here is our introduction of the Vision products. We have two series of products. One is short range LiDAR M30S, which is the largest field of view blind spot LiDAR for current applications in the market. It has 140 degrees of field of view in the horizontal and 70 degrees of field of view in the vertical, with the 20 meters of detection range at 10% reflection. So it has equivalent to 116 lines of scanning pattern, and so this can provide the vehicles with very high precision and very high resolution detection of the blind spot for the surrounding view of the vehicles. And for the long range LiDAR, we have the product MLXS, which has been into the B sample stage, and we have actually it's 120 degrees of field of view and 25 degrees of vertical view for the FOV, and up to 200 meters of detection range at 10%. Also, it has 200 lines of vertical equivalent lines for the high performance detection, and the vertical resolution is 600. So actually, this is a very high performance of the MEMS LiDAR so far in the world, and it targets to be SOP by end of next year. Okay. Yeah. Oh, sorry. How to remove this? Okay. This is our short range LiDAR with 140 field of view and 70 degrees of vertical view and 116 lines. It has already hundreds of design wins with our customers, both in China and abroad. And our first design win is with Inception for last year, and we have already another design win for JD and shipping thousands of units for this year with Jingdong last mile delivery, and also we have design win for the road taxis with Mobileye. So this page is point cloud, a demo point cloud for our short range LiDAR. So this is just a picture. Anyone is interested in this can reach out to me, and we can share more information face to face. Okay, so this is 300 by 160 lines of short range LiDAR, and it can very clearly show the pedestrians, the cones, and everything like side roads and vehicles, bicycles, motorcycles, cars, everything. This is our long range LiDAR, 200 meters at 10% reflection with ultra fine resolution of 0.1 degree. It is up to 200 lines of resolution for the vertical and 600 of points in the horizontal. So this one has been into B stage, and we are targeting the mass production by end of the next year. So this is currently also has a very compact size with only like 20 centimeters for the wide and 4.5 centimeters for the height. This is a demo of the long range LiDAR point cloud just shot a few months ago, and you can see that the LiDAR has been able to reach very high performance for the road lights and for the reflection rates for the road marks. Current our LiDAR products has been widely used in commercial vehicle, last mile delivery, and the robots. And right now we have already design wins with commercial vehicles like Inception, and also some other commercial vehicles in China. Also, we have one of the biggest PO in the last mile delivery for Jingdong, and the third generation of Jingdong's robots deliver cars is being released just a few days ago, installing 4 units of our ML30S LiDAR, and being shipping in hundreds of thousands of units this year. And also we have design win with Mobileye, the robotaxi solution and ADAS solution supplier in the world. And Mobileye has using 3 long-range LiDARs and from Lumina, and 6 short-range LiDARs from ZVision. And they have been released the total solution in Germany this year, just 2 months ago. Here's a brief introduction of our company. ZVision has been founded in November of 2017. We are a 4-year-old company right now, and we believe that we are a very young company, a very young LiDAR company in the industry. And right now we have been closing about 6 series of funding in the last 4 years, and by end of this year we will close another 2 rounds of funding with Pre-C and Serum by end of this year. And currently ZVision has 200 plus employees in Beijing, in Changshu, and Shanghai, and the US. And we have 4 offices in China and the US. And our facility is built in Changshu, and we have like 250K of production capacity every year by end of this year, and we will be qualified for 16949 by end of this year for the mass production. Okay, thank you everyone. This is the introduction of the vision, and anyone interested in the MEMS LiDAR technology can reach out to me, and we can discuss more details later. Thank you.
Thank you, Dr. Tuo. So this is now a time for the Q&A. That's great. So let's bring up all the panel speakers. Can all the panel speakers turn on your video so the audience can see you? Great. Kevin, can you help to, while I'm asking some questions, you can help to collect questions from the audience, from the chat and Q&A. So later on, I'll turn to you to ask some questions from the audience. Is that okay?
Sure, I'll try to do that.
Yeah, so I have a question for all the panelists. There are 800-pound gorilla in your industry. His name is Elon Musk, right? Especially in autonomous driving. So he's claiming LiDAR is not needed. So this is a little bit, I would say, controversial in this crowd, but I'd like to hear how you think you defend his statement about just using vision cameras to do the job and no need for LiDAR. So I'll start with, I guess, Dr. Pei Jun. Can you get started?
Yes, sure. My dear friend Elon from school days. Sure. So there are actually a couple ways of thinking about whether LiDAR is needed for automobiles. First and foremost is how you consider its function, whether is 5 years ago, it was very much considered as the enabler for autonomous vehicles. If you think that way, I think there are lots of debates can be established around that topic. But for us, or for me personally, I don't think LiDAR as a enabler for autonomous vehicle operation to start with. I actually think it as a sensor for safety. That's the first and foremost thought in my mind. So, for its function 3D detection, I actually make a very much of a analogy between your eyes, your nose, and your ears. You do have cameras, you do have radars, but don't you need another modality of measurement to boost your safety level to a higher standard? This is where everybody start to get excited that the desire for additional level of safety is never going to end. Once you have 90% safety level, you want 99%, and then you want 99.9%. You keep on adding the nines towards the ultimate goal of 100, where you will never reach. But this desire going there in either automobile or aviation industry will never end. So that's the fundamental for this. Then you start to establish yourself as to, what's the price cutting point for this device? Is it going to be, for space station docking, as we saw in the pictures, cost a few $1 million a piece? Or is it as a Cepton LiDAR delivered to General Motors cost several $100s a piece? You ask yourself, for several $100s, would you like to boost your safety level to a higher standard? The natural answer is yes. You would rather pay for that safety level. Then, then coming down to Elon, my dear Elon, who actually are so against it. There's the commercial aspect of this, frankly speaking, that by the time when I bought my first Tesla in 2013, 2014, he already said all the sensors already exist on their Tesla cars, and it's just a matter of turning on the software to become a full self-driving. And there's a commercial aspect of that. You can't go back and say, oh, suddenly I need a LiDAR. So the message has to be pretty straightforward there to make it work with whatever they have on the car, regardless of the safety level. So you actually already witnessed the safety factors of the full self-driving of Tesla. So I don't have to speak more about that. Sorry for making a large statement on this. Since you have me on the first, I'll take it.
Great answer. So anybody else want to take on this one?
Yeah, I would add on just from basic physics point of view and data processing point of view, both frame information from the camera and from the LiDAR are similar. But when you're processing the frame information, if using camera, you need to require enormously huge calculation power. LiDAR has the advantage. I think Yimin Li had showed the image of basically for a moving target, you need 6 digital information to tracking it. But if you're using camera, it's more complicated. So that's why, for example, the current implement in China, V2X, why even already deployed lots of camera on the street, but still they want LiDAR because the computing power is required significantly less than processing digital image.
Okay, great.
Yeah, I think I can add another point here. Like just Ben mentioned that, actually Elon, basically he mentioned that human can drive just with your eye, right? But that's not true. Actually, with your brain, you think about it, right? When you look at your front, like say there are 2 people there, immediately if there's a senior people or it's a child there, right? So you can, based on that judgment, if you will go through or you will stop, so basically your brain is working. So, but in that sense, our AI, I think right now it's not so powerful yet. Our AI is not so smart like our human being. So still, I think it's still far away unless our AI can be so smart to make all judgments. And that's another point. Also, I remember I have read one paper say that the brain processing the image, it's in microsecond, but our AI right now only in a millisecond. So it's still, I mean, the order of 3, power of 3 kind of difference there. So I think it's, unless we get really good AI there, we may say, okay, we may get rid of the LiDAR. I think it's really far away.
Okay, great.
Yeah, I think I half agree with Elon Musk and half disagree with. I agree with Pei Jun said that the 99.9999 V69 security level, yeah, that's something has to be done by LiDAR. But I kind of agree with Elon Musk is that the cost. We are doing the commercial business. I think one major issue in LiDAR now is the cost is pretty high. I think the basic reason is that the supply chain is not mature. With this self-driving going up, we see L3 and L4 autonomous driving moving up. I think we will going to finally have a mature supply chain. For example, the laser, the optical sensing, detectors, right? And also the following processing circuits. So all those now are keeping a very small volume, and many of them we are taking from the telecommunications, right? So, but I believe that with the booming up of the 3-level and the 4-level autonomous driving, and with the companies, startups working on those, brand new ICs, this situation going to get better. Thank you.
Okay, great, thanks. So this is actually a good segue to ask you a question. Obviously, many of you, if not all of you, but many of you already have backgrounds in optical communication, because that's where I think we get our wear and tear, right? Going through a few cycles, from beginning of technology all the way up and down again, and then up again. So certainly this is a journey I think many of us share, right? Starting from a new technology, then all the way scaled up and see the price drop, and then go through that learning curve. So I'd like to actually ask a question, because I think many of our audience here, probably, I can venture to guess, probably more than 60–70% actually already are in the optical industry. What do you see as I guess the communication, especially the optical component side, can help you? So maybe, each of you have your wish list. Like, what do you want to see from, Li Chen just said, supply chain side? Like, what help do you think you need in terms of going through the cycle with the learning curve already done in the communication side? So who want to take that first one? Maybe Tuo, you sort of just switching from communication to LiDAR, so maybe you can speak first.
I think that so many of the participants in the LiDAR industry has been shifted from the fiber communication and optoelectronic devices. So LiDAR is just very similar to transceiver modules for the fiber communication. There's the transmitter, receiver, modulation, and also the digital signal processing. The difference is the LiDAR module is much more complicated, and it has to interact with itself and isolate from ambient and exterior signals of interference. So, but generally speaking, I think the foundation technology, the basic technology are very much similar, from the semiconductor devices, materials, to the fabrication process, and to the assembly process, and to the system level. I think for the LiDAR industry to go into mature, it also needs thousands and millions of researchers from industry to come up together and contribute and exchange with best ideas and evolve with time and the industry. Okay.
Okay, thanks. Yimin, you have anything to add?
I think from our experience, we need the semiconductor technology. I mean, from the silicon to germanium to InGaAs. So I think we need good laser diode. We need good detector, and also we need powerful SoC. So I think that's the key ingredient down the road to achieve our goal. So we work on that ourselves, and also we invite a lot of other people who have the interest and the capability to join us.
Okay, great. Anybody else want to chime in on this?
I try to add up something, so I see there are two trends on the LiDAR, which is 1550 and then 905. And the 905 side always say that 1550 is pretty expensive. I think everybody knows about that, right? If we dig deep about the reason, we could see that if we use indium gallium arsenide, the wafer is 4 inches big. So, and also the yield is pretty low. How could that price be, very cost effective, right? That's kind of, impossible based on, current semiconductor, capability. So, but for 905, we know the, eye safety issue, blah, blah. The detection range is kind of limited, right? So I kind of agree with Yimin, the breakthrough we should down from the very basic semiconductor level, right? For the 1550 nanometer, if you take this route, what you think is how you can get the chip, for example, the laser and the photo detectors. Then you put those components into one system, you try to lower down the cost. Yeah. So that's the reason, VisionIC is focused on the semiconductor side, very basic level. We try to provide our SPAD, either on the 905 nanometer or even the longer, wavelengths, and also we provide the monolithic entire, depth computation engine, and also any kind of interface high speed like a MIPI and the DVP to try to match the LiDAR system. Yeah, I think that's a big direction in the future for the LiDAR industry. Thank you.
Yeah, I would like to add something else. Since some of us, including myself, had been working telecom, I migrated into this new field. I feel this is a very good adjacent market for the people still working on telecom to expand their business, because currently the ecosystem in the LiDAR system is in the early stage. So there's many challenges, including the cost reduction and the improved performance for better reliability. Lots of subjects we can, envision the opportunities. And you don't need to be the system solution provider. You could develop your unique skill and to produce specific components for this LiDAR application. For example, the traditional mirror, the traditional coating is required in the window of the LiDAR. Doesn't matter 905 or 1550. And you still need a lot of lens, which is traditional optics skill set required. In addition, doesn't matter 905 or 1550, you need a laser, chip package, and also module package. In addition, 1550 may associate with additional requirement of specialty fibers. So for the telecom grade, expert, there are many opportunities in 1550 or 905 LiDAR supply chain. So please pay attention and also jump in this new field, and let's work together like in the older days, telecom booming, make another booming in 2025 to 2030. Thank you.
Okay, thank you. Let me bring up another topic. Many of you actually, I observe, some of you, I certainly purposely invite some of you from China, some of you are based in US, and actually many of you are like based in both, right? With team both in China and US. So just like to ask you at least to share your view, like how is LiDAR development different? Or whatever angle you want to apply, but in China market versus in US market. Who want to start? Beijing, you want to?
No, I think I'm least qualified. We don't have a China office. So,
yeah, but you probably made some conscious choice by focusing in the US.
Absolutely. So, we actually had a very conscious choice of actually developing the market in North America, Europe, and Japan first. And that's our focus to start with. And it was our thought, right or wrong, it's our thought that once we occupy these three major automobile markets, China will naturally follow in terms of technology. Apparently, that ended up being, right in some ways, but wrong in many ways. That now in the LiDAR industry, China is really prospering with so many companies. So I'll stop there and let others chime in.
Yeah, I believe the biggest shipment of LiDAR is from Valeo, Germany. They put on the car, Audi and some other cars, Scala 1, Scala 4. The second one is Velodyne, goes everywhere. And the China may be the biggest potential booming market in the next few years because regulatory is not too tight. While in Europe or in US, Korea, Japan, the regulatory issue could be the showstopper or slow down the deployment.
All right, Yimin, you are uniquely positioned. You started in US, but then you end up doing a lot of work in China. So
I think yes, we are unique because our technical solution, majority of our supply chain are in China. To be honest, we can buy almost everything except for the ICs from China, and also because the solution we select is kind of highly rely on the skilled optical workers, and very hard to find those workers outside China. And to us, because our market is not only focused on autonomous driving, we are also focused on the smart infrastructure. I think for smart infrastructure, the so-called V2X, China is kind of leading because the government is kind of promote the application, and also their license regulation. So we think about this, that there are 5 million kilometer road in China. And if you apply 5 units per kilometer, that's 25 million units. Given 3 years lifetime, that's 8 million units per year. That's a pretty sizable market. And also it's life critical for the, so you are not required to be auto grade. So you work up to 55 degrees, 60 degrees, that's perfect. And but you need to fight the other end. You need probably work at minus 55 degrees to survive the northern part. So from our perspective, the supply chain, the labor, and more than half of the market are in China. So we cannot ignore that part. And I agree. So if you can lead in US or lead in Europe, you can transfer technology. But nowadays, I think that the world is kind of split. So basically, from our geography, our market is China and the world outside China. So that's our view and our strategy. I may not apply to everybody here, and I think everybody, each one can figure out their own way to sail in this angry water, or this challenging condition, I would say. So, but we also emphasize on US too, because we have a lot of we have a big facility here in Silicon Valley, and we were trying to manufacture in Silicon Valley, so that turned out to be not very successful. But,
hopefully Biden can give you some subsidy for doing that.
we hope so, but very challenging. But I think in US also there are lots of a new concept, and also lots of smart people, really smart people. I think all the people here are also very smart. I learned a lot from people here, and I got lots of help from the people here. Even lots of panelists today, we are working with them and receive help from them. So we emphasize both sides here.
Yeah, let me turn to Tuo, because you are really starting from China. And how do you see, I mean, you've been spending a lot of time in China, obviously. How do you see China market? And then comment a little bit, what's your view outside China, or do you have any plan?
Yeah, we started in Beijing, in China, and actually our first year of market presentation and market is in 2019. We, travels a lot to the US, because at that time the US market is more active compared with China for 2019. But since the COVID-19, the China market has been booming. And from the logistics and last mile delivery and the robotics and V2X applications, and also the ADAS applications driven by the new EV companies, for example, like X Motors, like NIO, like Lixiang, and also the Zeekr, also Zhiji, and some other companies in China are all the new EV companies in China are all pushing their high level ADAS applications and targeting mass production for 2022, 2023. So the China new EV customers are much more aggressive compared with the US markets. Like Cepton just won the design win for GM. But GM is targeting mass production like in 2023 or 2024. But the China customers, they are targeting like 2022. But the China customer, they plan for the projects the time is much far behind the US companies, but the action is very fast. So the China customers are actually leading the mass production. Currently, I still don't know how the general consumers, how they feel about the products and how they feel about the ADAS applications, what can bring to their life, to their travel, to their driving experience. But currently, the consumers in China are all very active and very favor of the new features of the vehicles. So I think the China actually is moving very fast in the last 2 years, and we can see that the customers are also the consumers has a very high level of acceptance for the LiDAR applications. So this is what we see in China. And we see that also for the last 2 years in the US, we have a lot of customers there, and they are moving slower compared with 2019. So So one is fast and one is slower. So this is very interesting. So I think that after the pandemic, there are a lot of things to be done in the US to take the lead again.
Yeah, look like US has some catch up to do, right? So let's quickly bring up another good contrast point. Certainly there are traditional car makers. Then there's so-called 造车新势力, right? Basically the
new EV.
aggressive new car makers. What's your view there in terms of targeting and winning the business? I guess each of you may have different take on this. Who want to go first?
I totally believe that new EV is going to lead the China market in the next 5 years. They are more aggressive and more innovative, and their execution is very good. And also their intelligent engineers are very, working very hard. So yeah, I think they are going to lead.
Anybody else?
Yeah, I think the new EV chose us. We are not chasing them.
How about Continental side? Ronan, you are muted. We cannot hear you. You are muted.
Oh yeah, okay, got it. Okay, sure. Actually, Continental, we had like a experience for over 20 years, right? Also for like this flash LiDAR, we claim we are the first one that went to SOP. There's nobody else right now, seems like, right? So we're the first one, but still, I think because the car maker, I think they are not really ready yet to really go mass deployment. So even we already had SOP here, so the order there, you know what I mean? So it's still not taking off yet. So their schedule is still like go to maybe 2023 or 2024, or even later to really go like a mass deployment. So that's kind of thing we are kind of have a gap there. So that's one thing. But also I think I agree with Tuo. I think China, maybe they're really going faster right now. Their implementation, everything's going fast. Like for us here, we made this, to SOP, but we really spent the years to really get that done. So we learned lots of lessons for that. So yeah.
Beijing, you have anything to comment?
I guess I agree with everyone. Just looking at the EV numbers from China is astronomical, and it's actually that place everybody is beating up Elon Musk at their own game.
Yeah. Okay, I will ask a question here. In LiDAR field, there's some of the numbers people almost like, mine is bigger, mine is longer, and certainly Benhua really planting a flag here says, I have 1,001 kilometer range here. So first of all, I just like to ask Benhua, you did not elaborate. Is there really need for 1,000 kilometer kind of range, or what is a particular use case for that? And then for everybody else, how do you see the range game here?
Okay, so for the range in ADAS application, the truck need a long braking distance. So that's why they need a 1,000 meter detection capability to the automobile, not to the pedestrian. Second, for the ITS system, just like Yimin said, currently is 200 meter a LiDAR. So if the next gen LiDAR can reach 1,000 meter with a much better resolution. So for freeway, smart freeway, you just need one LiDAR for 1,000 meter. And also for certain application in airport, in harbor, you need to do the surveillance on the airplane and the shipping cargo. You need 1,000 meters. And I believe AI is not the first one to claim that. There are some other company also claim using 1550 LiDAR system. And their system is mounted in a real harbor to monitor the traffic of the boat. Their working distance is over 1,000 meters, so there's a need. So in addition to that, the airborne surveillance needed that. Even nowadays, people talking about space mapping because so many satellite debris in the space, you need that.
Probably more than 1,000 kilometers for that case.
Oh yeah, yeah. In the space, it's totally different animal because there are no air turbulence. It's a very stable environment. Yeah, so you can travel much longer than that.
Okay. Anybody else want to chime in on the range or how important the range is?
From outside, yeah, from outside, we think that range means something when it has to do the final applications. For the long range detection in high-speed highways, the range has to go up to like 400 meters, 500 meters, but rarely it rarely needs 1,000 meter for the highway. And for the city mapping, city pilot, maybe 100 meters is already enough because you can never drive too fast. So it corresponds with the response time of the vehicle, the decision time, the perception time, and so 100 meters is for the civil pilot, and 200 meters to 400 meters for the highway pilot. That's our think of the range competition.
Yeah, let me concur with that with a bit of a number illustrated to everyone. If you're driving 70 miles an hour, that's 120 kilometers per hour, your speed is roughly around 35 meters per second. So a 200-meter range of LiDAR will get you about 6 seconds of reaction time, 5 to 6 seconds. So take some braking distance away from it, you still have 3 to 4 seconds of reaction time. Is your computing system fast enough to actually react with that amount of time? Certainly for a human being, it can. So then you ask, if you go further in distance, what problem are you trying to solve? So these are the natural questions coming to the requirement. For me, for Cepton Technologies, well, Yimin knows this. I started a small company after my Velodyne days, and it's a very small metrology company that actually made money for me. And so I actually claim to many that I came from a small business background just because of that small gig. And since then, that mentality chimed in to the Cepton technology path as well, that yes, absolutely, I agree with Ben, and there are plenty of applications and need for long-range LiDAR, but for the biggest market, where you actually have the number of passenger cars with the biggest number of applications, is actually you want the lowest cost possible that will satisfy the need. At this point, as far as I can, I'm starting a debate perhaps here that the consensus among the OEMs I'm aware of is 200 meters at 10% target is actually plenty for the ADAS application in level 2+. A lot of descriptive words there, but I'm confining myself to the biggest market, biggest money-making possibility for LiDAR.
Great, thank you. So we are getting close. Kevin, do you have any questions from the audience? You can pick one or two to ask the panelists.
Yeah, I did capture several questions. What time? When do we stop? 8:30?
Well, we already blow through, I think, close to half an hour. So just maybe 2 questions.
Okay, let me pick up the most important one. Several people asked the LiDAR performance during the rain, fog, or snow. Could you, questions, I guess, is does it really perform, right? And my question is, does it really required, right? And today, if it is rains heavily or snow heavily, fog heavily, you can't drive that fast, right? You have to slow down or don't drive at all, right? So please comment on this. Anybody?
Yeah, bad weather. Anybody? We just had a bad weather a couple of days ago.
Nobody's LiDAR perform?
I think I drive a car with radar. In the poor weather, you need a radar. In addition to LiDAR, you need a combination of two sensors to make a self-driving, to reduce the risk. Although some vendors' LiDAR system, including maybe some of the people presented here, they had to try the field in the snow, in the raining. Apparently it's okay, but you never know in the worst scenario situation. So that's why for safety, usually people asking for second sensor, which is a traditional millimeter wave radar, which is very good in penetration in the severe weather condition, raining or snowing.
So Elon Musk is real trouble, right? He got rid of radar, he got rid of LiDAR, he got rid of all already. Okay.
I think in bad weather, we
Anybody
have some reduced performance, but the major challenge is to keep the window clean. So basically, we want basically how to improve the robustness of the device itself. And everybody understands that. So if it rains very heavy, you cannot keep the original ranging spec. But that's okay. You will drive slower, right? So even like you guys said, if it drives really hard, if it rains really heavy, probably nobody will drive, right? At that time, your brake may not work that safe. So why bother to risk?
What is the rough benchmark these days? Like you say, have a normal rain, you're gonna see how much reduction of range?
From our perspective, if you got some 20-30 millimeter per hour, we see some 10% to 15% drop, but it's not that significant. And for fog, probably you need some upgrade to overcome the fog. And our LiDAR can see through dust. We have demonstrated this capability in lots of application scenario. So for fog, I believe that a similar thing. So you have reduced performance, but it's not the end of the world.
So in general, LiDAR would help us to do better than just human eyes. Is that fair? Fair answer?
Yeah, that's true.
Okay. All right. Thank you, guys. We bring another question. Let's say an easy one. This is somebody asked if, I guess, multi-cars or maybe even all the cars are equipped with LiDAR, how do you address the interference to each other?
Crosstalks.
Yeah, crosstalks between, everybody's using 1550 if that wins. So how do you address the interference between different LiDAR emissions?
I would like to answer this question if no others want to give comments. So it could be done, and actually it has been done. For VisionIC, so each LiDAR, solid LiDAR device, we modulate the laser frequency. So for example, you have 1,000 laser, you have 1,000 LiDARs, right? Each LiDAR's transmitter was frequency modulated, with a specific code. So for this case, even two LiDAR, they are facing each other. Since they are not emitting the laser at the same time, so also the receiver know when my transmitter send out a signal. So at this scenario, the interference will not happen or we could say that the possibility of the interference is going to keep low. Yeah.
Thank you.
I add on to Cheng Li's principle. Just recall, since most of us are working telecom, when we do DWDM or multi-channel add-job application, we tracking the channel ID using tune, dieseling the channel, particular channel wavelengths, so create the channel ID. So for the LiDAR, this principle could be applied too.
Well, that's very limited, right? It's a WDM, you got 80 channels or something.
No, dieseling is a wavelength or frequency jittering. It's endless.
Okay.
It's
basically
it's a architecture lucid pattern.
Some coding and decoding.
Yeah, coding, decoding. Yeah.
All right.
Yeah, I think in the RF world, you already done that all the time, right? As long as you code it properly, I think you probably can find good ways to use the orthogonal techniques.
Yeah, actually,
is that building? Just curious. This is something to be done, or this is already like built into your LiDAR? Any of you already built into your LiDAR to overcome the interference or crosstalk?
yeah, I think like in Continental, we have been done some kind of research on this. But basically, I just adding to the points the two panelists just mentioned that. So the probability is really low. Think about that. Let's say if you use a TOF, right, TOF, you send a pulse. Between the pulse, your pulse has only like few nanoseconds, right? So your frame rate, so the another one just exactly aligned with your pulse within nanosecond. So that probability is already like a 10 to power of 6, 1 over that. So your probability, even without coding, your probability is pretty low there. So in addition, if you add some coding there, I think this is not really a critical issue there.
Okay.
So,
unless you use continuous wave, or if you use FMCW, that condition could be a little bit different.
Yeah, that's you know, having CW technology today, we don't have anybody representing that technology today, but that's, I think, what they claim is one of the advantage, right? Because they're using this coherent mechanism. Lots of people ask for that, but today we may not have time to address FMCW or ask you guys to comment. That may be a good idea, Ryan, that we could do another one, that inviting some of the FMCW players into this.
No, I think we can certainly still ask the panelists to comment on FMCW, because this is fairly new, and you know, some of you probably are thinking about it. So how about just any of you actually thinking about doing FMCW? Because this is something just like communication, right? You start with simple, and then you know you go to more complicated down the road. Especially, we're talking about very much parallel development here. You start with AM, then you may go FM, right? So what's your view there? Maybe just, you know, some of you might chime in or comment.
I think I can talk a little bit. FMCW, I think is a future technology, at least 5 years away. Giving example for the Mobile or Intel. They already claim they are jumping into this field, and they said that the delivery date is something like 2026. And on the other hand, I would say FMCW may not be the right term. I think people just too lazy, just copy the term from millimeter wave. And I think you copy the word is very easy, but you mitigate from millimeter wave to light wave. Probably you need to change something.
So what do you prefer to call it? Coherent detection?
Yeah, that's the term, coherent. Yeah. So I think the people, all the advantages from coherent detection is not from how you modulate the light. And you exactly copy the same modulation from the millimeter wave I think it's a nightmare for optical wavelengths, so optical frequency. But probably you can, I believe people are smart enough, they can figure out something different. And but I think it's it will be something out there, but I just don't feel we are ready yet.
Yeah, I think for the FMCW LiDAR is already deployed in certain industry like wind turbine to monitor the air turbulence. But for automobile or for some dynamic application, the frame refresh rate would be a concern for FMCW or coherent detection, as well as for the long range, how to steer the beam to detect like a 200 or 300 meter away the moving target. It's very difficult to tracking and steering or lack of a mechanism of scanning.
Right.
Yeah, just in addition to that, I think, county is a tier 1, right? So we are keep tracking this all new technology there. We like basically, every few months we are looking this new startups, new technology there. I think like I say, FMCW still kind of far away, a little bit far away, or in the sense of a futuristic technology. Like we see a few companies, they make this coherent detection on the waveguide. So, waveguide, you can draw a very good PowerPoint for the waveguide implementation, but in reality, when you're doing that, it's lots of issue there. Like for the beam coupling, right? Lots of loss there. For beam splitting and also phase control, all these kind of issues there. So we say like one company, they are really limited, like they're splitting the beam on the waveguide into 1/16 beams shooting out. Then you can see the resolution is only 16 beam, right? So scanning of the 16 beam, and it's almost kind of the max they can do there on the waveguide. So I mean, definitely this could be the future technology. So, but right now I think it's too early to be commercialized for that.
So Tuo, 5 years ago, 3 years ago, no, 3 years away?
For FMCW products, currently the FMCW technology is in the demo type. So currently we still cannot call this FMCW as a product. So for the mass production, for the product level, it has to be, the cost has to be within $1,000 for the volume shipping. And also the performance has to catch up with current top LiDAR performance. So I think it's still 5 to 10 years away for the mass production. And the bad news is this, and the good news is that for the researchers, for the engineers, for the participants in the industry, there are a lot of opportunities for the FMCW players to catch up with the market. So yeah, and like for 5 years or 10 years later, the market penetration will be like 10%. And there are still plenty of room for the new technology to come up and to win the new opportunities.
Oh, by the way, here, I think there is a company called Aeye, right? So I heard that they are kind of have the demo units to be delivered. So anybody has any information there for Aeye?
But you are saying they're in trouble, right? Their whole company is banking on it.
Actually, right now they already went to IPO, right? Their market capital is more value is more like $1.something billion right now.
Yeah, they did.
Yeah, Aeye. I don't know anybody has comments for that.
Well, we may invite them, maybe a follow-up workshop. Any other comments? I think we really appreciate all the panel speakers really run through a very, actually long time. We already run through, what is now? 8:40, wow. So I think we should wrap up this workshop. Really appreciate everybody. Thank you so much. Really appreciate it. I actually like to invite all of you at a certain time to meet together, sitting face to face. We can talk and have a lot to talk about.
Okay, great.
Yeah, thank you so much.
Yeah, thank you.
Thank you.
Thank you.
Thank you. Bye.
Thank you for all the knowledge.
Bye.
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 See you soon.